Here's all my working answers at the beginning. In case you just need one little part of that, just go to work on that and spark your brain there. But for letter A, it has a limit problem as x approaches 0. And so I'm going to take 0 and plug that in for the top function and the bottom function. And it tells us that f of 0 is equal to -1 right there. So when I go -1 plus 1, I get 0 up top. Sine of 0 is 0 on the bottom. So since I got 0 over 0 format, I'm allowed to use L'Hopital's rule. So I do the derivative of the top, the derivative of f is f prime, the derivative of sine is cosine. Just do the derivative of the top and bottom, use that L'Hopital's rule. And then your derivative is the same thing as dy dx. So they gave us the dy dx. So I just wrote that function right there. And then I carried down my cosine. Now when you plug in 0, it's a limit as x approaches 0. Usually you just got x's in there, you just plug the 0 in for the x, right? But you have x's and y's in there, so it's a limit at x equals 0. Well, at x equals 0, the y value is -1. That's what it gave us at. That's the only other point in the problem, so you got to use the point 0, -1. So we'll take the -1, plug it in for the y. Now when you square it, it becomes a +1. You plug the 0 in for the x, so you get a 2, and then the cosine of 0 is equal to 1, so we get 2 for that limit answer right there. Letter B was the Euler's method. I like the Euler's method. I like when it pops up on the AP test because it's very similar to the videos. Every time I've seen it pop up on there, you just got to practice this without the use of the calculus. So here's the entire Euler's method. It tells us we're going to start at 0, 2 equal steps to get to 1/2. So to get from 0 to 1/2 in 2 steps, that's a quarter, and then another quarter to get your 50 cents, right? So your delta x is the 1/4 or 0.25. And I'm pretty much going to use fractions throughout this whole thing. It helped me on this one instead of the decimals. So there's your starting point is the 0, -1. That's what they tell us to start at. And then you're going to go delta x times the dy dx. So you're going to take the 1/4 as your delta x, times it by the dy dx. Now at x equals 0, we already kind of work with over here. You're plugging in those numbers for your derivative. That's kind of what we did right here, where I knew that top part was going to be equal to 2, but you're just taking those numbers, plugging it into the x and y for your derivative. You're going to get 2, which is 1/2. And remember, to get this last number on this column, you add up this number plus this number. So -1 plus the 1/2 because it's -1/2. That's your new y value. And now your x is the 1/4, your y is -1/2. So you're going to do delta x, which is still your 1/4, and you're going to times it by your dy dx. So you got to take the 1/4, plug it in for x into your derivative, take the -1/2, plug it into y for your derivative right there. That's where we're plugging those x and y's into, is that derivative right there. So I went to the side and I did that over here. So there's my y value. So I gotta go that thing squared and then 2 times the x value plus 2. So did basic arithmetic there, half. 1/2 plus 4/2 is 5/2. And then you take that times a fourth, you're gonna get 5/8 right there. That's just the dy dx part. Multiply those together to get the 5/32, and then you got to add up the -1/2 plus the 5/32. You see my work there. I just got a common denominator, one single fraction. Boom, got the -11/32. That goes right there, and that's what they wanted us to approximate, is f of 1/2. So then f of 1/2 is about that -11/32 line. Okay, so we'll be perfect with that Euler's method there. You just got to practice that without the calculator. And then when it tells us to find the particular solution to the differential equation, that's when we're going to integrate both sides. Remember to plus c, use a point to figure out what that c value is. So the first thing you got to do is move the dx over there, and then you have to get y's with the dy. So do legal algebra, move the y squared over, y's with the dy, x's with the dx. That's just a y to the -2. Remember, that's not an ln just because you see 1 over something. It's not 1 over a single letter. So you make that y to -2, go y to -1 over -1, which is -1 over y. And then you got your easy integral. Always take the plus c on the side the x's are on. Use that initial condition that they give us to plug the -1 in for the y, plug the 0 in for the x to obtain that c value, plop that back in right there. And then all of these seem like they're having us solve for the y because it says y equals there. So I just multiply by y, get it out of the denominator, then I divide both sides by that trinomial. Pomegranate juice.